In this video, we are going to be looking at average rate of change and instantaneous rate of change. Average rate of change was the same thing as the slope of the secant line, and so is average velocity. So as we look at question 1 or question 2 here, it says a small steel ball is dropped from a tower and will fall a distance of y feet in x seconds, as given by the formula y equals f of x, or 16x squared. Finding the average velocity is the same thing as finding slope. So if we do that from 1 to 2, our formula would be to find the value at 2, subtract from that the function value at 1, divided by 2 minus 1, as we've done slope in the past. So f of 2, we would understand, would be what we get when we substitute a 2 into our formula, which would give us 16 times 4, or 64, and that would be in feet. That's how far the ball would fall in 2 seconds. F of 1 would be the 16 times 1 squared, or 16 feet. So if we do this, we're going to get, we substitute f of 2, that would be our 64. F of 1 is our 16 over 2 minus 1 seconds, giving us 48. Now, again, our units in our numerator are feet. Our units in our denominator is seconds. So our answer is 48 feet per second. Then it wants us to find the average velocity in simplified form from x equals 1 to x equals 1 plus h. So here, what we're doing is finding f of 1 plus some distance h minus f of 1. Over 1 plus h minus 1. This, since the 1's will cancel, just be over h. This is the formula we had above. So we must find what f of 1 plus h is, which is what we'd get when we plug 1 plus h in for x. We must remember, this will happen a lot, that when we're squaring a binomial, we have to FOIL it. So this will give us 1 times 1 is 1. 1 times h is 1h. H times 1 is also 1h. And h times h is h squared. So we get 1 plus 2h plus h squared. Cleaning that up, it'll give us 16 plus 32h plus 16h squared. So this is this part of our numerator. So we'll write that in here. 16 plus 32h plus 16h squared. From that, we must subtract f of 1, which we found up here to be 16. So we'll subtract 16. And in our denominator, the 1's cancel, we just have h. Now we want to simplify that. We notice on our numerator that the 16's will cancel. So we'll have 32h plus 16h squared over h. At this stage, we want to recognize that since both of the terms in the numerator have an h in them, we can factor it out. That way it can cancel with the denominator. So the simplified form of the average velocity from 1 to 1 plus h is 32 minus 16h, and that would be feet per second. Let's look at the next one. Now it wants us to talk about instantaneous velocity. So that means the difference quotient that we did above here as h approaches 0. So we take this function, the limit of it as h approaches 0 of 32 minus 16h, which will be 32 minus 16 times 0, which will be 16 feet per second. Excuse me, that's really 32. 32 minus 0 is 32. I knew that didn't sound right. So what that means is the instantaneous velocity, or the speed that that ball is dropping, 1 second after it's let go is 32 feet per second. Now let's look at our next problem. So, as introduced in the problem above, the instantaneous rate of change is the difference quotient with h approaching 0. So that's f of a plus some value h minus f of a over h, but when h approaches 0. We always do this part last. We simplify the fraction first, and then we take h approaching 0. Let's look at that in example 3 here. It says to find the slope of the secant line for a equals 2 and h equals 2 and h equals 1. So this is two problems. First, we're going to let a equal 2 for both of them. But first we'll check when h equals 2, and then we'll do when h equals 1. So wherever we see an a in this problem, we're going to be substituting in a 2. And in our first part, we'll be putting in a 2 for h also. That's going to look like this. The slope of the secant line would be f of a plus h, in this case 2 plus 2, minus f of a, which is 2, divided by h, which is 2. So this is when h equals 2, this one. That will give us f of 4 minus f of 2 over 2. Well, f of 4 means we're substituting a 4 into x squared. And 4 squared is 16. F of 2 means we're substituting a 2 in here. So we'd have 2 squared, or 4, over 2, which is 12 over 2. I'm sorry, yes, or 6. Then we want to do it when h equals 1. Let's do this in a different color. So when h is 1, we'll be substituting a 1 into those parts. That will look like this. We'll have f of 2 plus 1 minus f of 2 over 1. F of 2 plus 1 means f of 3 minus f of 2. Oops. Over 1. F of 3 means we're substituting a 3 in for x. 3 squared is 9. F of 2, we already know, is 4. So this would be 5 over 1, or 5. So this means that the slope of the secant line from 2 to 4 is 6, and the slope of the secant line from 2 to 3 is 5. Let's look at this on a graph. Right, so here we see our original point when x is 2, or when a is 2, the y value is 4. And then we wanted to go 2 units to the right because it said a plus h, and h was 2. So if we go 2 units to the right, we're up here at 16. And the slope, you can see what we found also was 5. If we change that to when a was 3, when h was 1, and that would be 9. Oops. You can see here's the secant line, and now our slope is 5. And that's what we got on our sheet. Let's go back. In this next part, it wants us to simplify the slope of the secant line for a equals 2, and h is any non-zero number. So here we're going to let h remain a variable. That will look like this. F of 2 plus h minus f of 2 over h. So f of 2 plus h would be what we get when we substitute 2 plus h into my function. So it would be 2 plus h squared. F of 2 we already found to be a y value of 4. And h in this case is going to remain a variable. Simplifying 2 plus h squared, we know we have to FOIL that. It's not really simplifying it, it's expanding it. When we multiply that out, we're going to get 4 plus 4h plus h squared. That's this part. Then we have to subtract 4 from that over h. Simplifying, we'll get the 4's to cancel, and we'll have 4h plus h squared over h. Further simplifying, we see that there's an h in both of the terms in the numerator. And if we factor it out, we have 4 plus h times h. Then our h is canceled in the numerator and denominator, leaving us with 4 plus h. That would be the slope of the secant line when a is 2 and h is any non-zero number. Now, if we take the limit of that as h approaches 0 of 4 plus h, we're going to get 4 plus 0, or 4. That's our instantaneous velocity. Now it says find the slope of the graph at a equals 2. Well, we just did. The instantaneous velocity would be the same thing as the slope of the tangent line. So the answer here is 4. Now, in our next video, we're going to be looking at the definition of derivative. Thanks for watching.